Hello, everyone! Welcome back to another episode of Learning Mathematics here at MTM Channel. I am Teacher Angel of Eulogio Rodriguez Integrated School. Together, let's be Math Tibay, Math Talino, and Math Galing. Today, I will teach you about the subsets of real numbers and the set of integers. Let us have first the subsets of real numbers. Competencies. The learner illustrates the different subsets of real numbers and arranges real numbers in increasing or decreasing order. Objectives. At the end of the lesson, you should be able to illustrate different subsets of real numbers and arrange real numbers in increasing or decreasing order. Let us now have the real numbers. The set of real numbers has different subsets. Real numbers can be defined as the union of the set of rational and irrational numbers in the number system. Subsets of real numbers. Under subsets of real numbers, we have natural numbers. These are numbers you've first learned. It can be called as counting numbers or positive numbers. Examples are 1, 2, 3, 4, and so on. Next is whole numbers. Whole numbers are combination of zero and natural or counting numbers. For example, 0, 1, 2, 3, and so on. Under real numbers, we also have integers. This includes whole numbers, not a fractional number, that can be positive, negative, or 0. For example, -3, -2, -1, 0, 1, 2, 3, and so on. Another subset of real numbers is rational numbers. This includes all numbers that can be expressed as a fraction or numbers with non-terminating and repeating decimals. These are numbers that can be expressed in the form of a over b, where b is not equal to 0. Examples are 1/3, 5, -9, 0.15, 0.12 with a bar. We also have irrational numbers. This includes numbers that can be expressed as a ratio of two integers. It has decimal that goes on forever without any repeating pattern. These are numbers that cannot be expressed in the form of a over b. It is a non-terminating and non-repeating decimal. For example, square root of 2, 0.121567, and so on. Let us see the subsets of real numbers in a diagram. We have rational numbers and irrational numbers. Under rational numbers, we have integers and non-integers. Under integers, we also have negative integers and whole numbers. Whole numbers, these are 0, positive integers, counting, and natural numbers. For the non-integers, we have percent, fractions, decimals. Under decimals, we have repeating and non-terminating decimals and terminating decimals. Under irrational numbers, we have non-repeating and non-terminating decimals. Subsets of real numbers can also be presented in a Venn diagram. Of course, real numbers is the universal set. We have rational numbers. These are 1 over 3, 5, -9, 0.15. Under rational numbers, we have integers. These are square root of 49, that is equal to positive or negative 7, 0, -5, 18, -2. We also have integers. These are the set of 0, 1, 2, 3, and so on. Next, natural or counting numbers. The set of 1, 2, 3, and so on. Of course, we also have irrational numbers. These are square root of 2, 0.121567, and so on, pi, square root of 10, and square root of 3. Let us see if you have familiarized yourself with the subsets of real numbers. Classify the real numbers to which subset of real numbers they belong. Use a tick mark to answer. You have 30 seconds to finish the activity. Timer starts now. Time's up! Now, let us track your activity. We have -15. It is an integer and irrational number, since it can be expressed as -15 over 1. Square root of 2 is an irrational number, since it cannot be written as a ratio of two integers. Next is 0 is a whole number, an integer, and a rational number. How about 5/10? It is a rational number since it can be written as 1/2. Last but not the least is 3/5. 3/5 is a rational number. Since we're done already with the subsets of real numbers, let us now have the set of integers. Definition of order on the real number line. If A and B are real numbers, A is less than B if B minus A is positive. The order of A and B is denoted by inequality A is less than B. This relationship can also be described by saying that B is greater than A. This inequality means that A is less than or equal to B, and the inequality means that B is greater than or equal to A. The symbols is less than or equal to and is greater than or equal to are inequality symbols. Geometrically, this definition implies that A is less than B if and only if A lies to the left of B on the real number line as shown in the figure. Here are the steps on how to arrange real numbers. Convert all the numbers to the same form. Separate negatives and positives. Compare one decimal place at a time. Write the proper order with the numbers in their original form. Let's have examples. Let us arrange the following real numbers in increasing order. -14, 25 over 2, 10.1, and square root of 50. The first step that we have to do is to convert all numbers to the same form. 25 over 2 is equal to 12.5. Square root of 50 is equal to 7.07. Next step, we will separate negatives and positives. All negatives are lesser than the positive numbers. Thus, the order of the numbers is -14, square root of 50, 10.1, and 25 over 2. Let us now have the next example. 6 students of grade 10 run the following distances in kilometers in 2 hours. John ran 1.3 kilometers. Ken, 11 over 3 kilometers. Paul, square root of 7 kilometers. Dan, 2.9 kilometers. Tim, square root of 11 kilometers. And Josh run 9 over 4 kilometers. Order the students by distance covered by them from greatest to least. Here's the solution. Since it's easier to arrange the numbers from greatest to least if it's in decimal form, then we have to convert the numbers in decimal form. So John, it's already in decimal form, 1.3 kilometers. Ken, 11 over 3, so that is 3.66 kilometers. Paul, square root of 7, that is 2.65 kilometers. Dan ran for 2.9 kilometers. Tim, square root of 11, or that is 3.32 kilometers. And Josh, 9 over 4, that is 2.25 kilometers. So the answer, if we have to arrange it in greatest to least, Ken, Tim, Dan, Paul, Josh, and John. You did a good job in applying what you have learned. Again, this is Teacher Angel of Eulogio Rodriguez Integrated School.